Okay, so one of the problems I was having was the little collision box. So right now the character is represented by two circles and a square, and they overlap, but there's not really anything I can do about that. And I was having a problem where this value being printed over here is whether it thinks it's touching the ground or not for the sake of jumping. So you can't jump while you're in the air. And I was having a problem where some of the time it would show as false, and I assumed that was because the circle was having trouble um, going over corners of these tiles, because that's why you have to use the circle in the first place. If you try to use the square, it gets snagged, and this is the known issue with libgdx or with Box2D. So I thought I would put a little sensor underneath this little tiny rectangle you can see here, but it's having the same problem except worse. And then it occurred to me that when you leave one box, what would happen is basically I would say if you end contact, it would remove you from the ground, and then when you begin contact, it would add you to the ground. So what was happening is uh, you would start contacting the next square, and then as soon as you left the previous square, it would mark you as not in contact anymore. So really, even with a circle, which should have a single point touching either of these boxes, the circle was beginning contact with the next box before ending contact with the previous box. So really the solution for that is to keep track of a counter of the number of contact points. So now it works pretty well. The jumping is, I don't know, I'm still tweaking that. The jumping is a bit high. So the move speed is a force, while the jump impulse is an impulse, and the impulses, I don't know exactly the math of it, but an impulse is a high force over a very infinitesimal length of time, and it just sort of modifies the velocity. Whereas the force is actually a continuous push that's meant to be applied over several frames. So also move speed is applied relative to delta time, which is why it's so small. Whereas the impulse, because as soon as you jump, you're not on the ground anymore, it's applied just once and is not scaled by time. So let's make this a little bit smaller. Not that much smaller. It's still sort of frustrating that when you hit the ground, you stop pretty hard. Not really sure what the deal is with that. I'm not going to worry about that right now. So now you can only jump. One of the next things I'd like to do is make it so that the terrain isn't just a big box. Let's see, we're going to say scale is 1 for now. And what we can do here is say, I'm just going to do like a sine wave. If sine of w times scale is less than height times scale. This probably isn't going to work, but that's okay. Well, it looks like it's doing something. Yeah, so this is sort of the point where I just start randomly trying things. So math.sine is going to be, the x values range from 0 to 2 pi in the usual sine wave. So let's see. The other thing that was sort of weird was it was showing up at the bottom. I'm curious what happens if I just flip this sign. Okay. I'm going to raise up the position a bit. Okay, that's not super helpful. But I can see what it's doing at least. So let's try, it's a quarter. Okay. At some point I just need to raise the player up again. So we're getting the top half of the sine wave, but the bottom half of the sine wave is going below 0, and we don't render below 0. So I just need to offset all these values. That's probably the wrong way, actually. Okay, well, so it's actually offsetting like side to side, it looks like, which if I had a better understanding of math right about now would make sense. But I guess I'm modifying. Oh, I was doing the math inside the sine. Okay, that's why. That makes sense. Because I'm just offsetting the value that I was taking the sine of. Okay, well that's starting to look like something. So it's still being, it looks like it's being truncated pretty hard. I think I might just want to increase the height. Well, that's going to be fun. I didn't realize it was going to get snagged like that. Let me just fix that right now. So what's happening is the box here is getting snagged on the corner of the other box because boxes and corners don't work very well in box 2D. So the box here doesn't even really need to be there. I'm not going to remove it, but I am going to make it slightly smaller. Here's the player. Rather than having a half width of 0.5, I can make a 0.48, let's say. Well, so you can see it looks slightly smaller. You can't, like some of the time you can see there's a pixel and sometimes there's not. Like here you can see there's an extra pixel there where the circle is. That's interesting. If I'm trying to walk, it sort of pushes me into the wall. But if I'm not trying to do that, you can see it sort of bounces off the wall a little bit. But you know, it moves you by like a pixel, so I don't know. I'm not really gonna worry about that. And I'm not even sure it's moving by a pixel. I think it might just be bouncing. Yeah. I don't know, that's not great, but it's almost a feature except that you can't even jump because you're not on the ground. Yeah, anyway, that's silly. Okay, so I think the problem is like, rather than just keep making the height taller and taller, I think I need to just reduce the scale of the world here. Let's see. Because it's on the right-hand side and saying if it's greater than this value, okay. I think the thing that's confusing is I think these values are backwards. You want to be, no, you want to take the sign of the x value and then okay, no, it's fine. So let's just try fiddling with this for a bit. Let's see what happens when we reduce the height scale by a lot. Okay, so I think this is a very tall shape. So what happens if we increase it again? Okay, let's see what happens when we do it again. I think this 1 needs to be scaled by that. Oh, right. If I added 1 and it became a whole. If I subtract 1, okay. I have no idea. I have no idea what I'm doing. Okay, whatever. It's not exactly a sine wave, but the point is there's hills. And that's really all I was going for to begin with. Like, the thing is that the ground is pretty high, reasonably high friction, so that when you let go, you just stop sliding. Hold on, let me turn off the physics. You won't be able to see the ground, but I'm going to turn off the physics debug system real quick. Okay, this is sort of weird. So I want you to sort of come to a, the character's supposed to come to a stop when they stop moving, but right now they just sort of slide. And the reason I do that is so that there's, well, I mean, the reason why it comes to a stop is because that's what you expect, but I'm just using friction for that right now, and it seems to work okay, except that something about the way it hits the ground causes them to always like completely stop. And I'm wondering if that's because it's just a circle hitting the ground at the right angle. I'm wondering if it's because of the friction. I don't know. The friction's not infinite though. I don't know why it instantly stops. That's confusing. I'm going to turn this back on. There's a few other knobs I can play with, but I haven't really read a lot about them. So if we look at the bottom circle, so there's feet here, but it's a sensor, the little feet box, so that it's not actually impacting anything. But there's another one. There's another property called restitution. Okay, that's not helpful. Okay. That's not helpful. Blah, blah, blah. So I understand density, I understand friction vaguely. Yeah, so restitution is bounciness, and okay, you know what? First I'm going to see if I set the friction to 0, what happens. So I can do that here. Yeah. If I set friction to 0, then this means that when you walk around, you just sort of slide indefinitely. I'm sort of okay with that because I can apply my own friction. I can be like, hey, you're on the ground, apply a force, and if you're on the ground and moving, it applies a force in the opposite direction. Really what I want to see. Okay, so now so now the problem seems to be pretty absent. It doesn't stick anymore. First thing, well, the thing is like, I'm sort of concerned that if I find if I find the right friction for I wonder if it's also getting snagged on those corners at all. Like, just keep hitting the corners. I don't know. It seems like if there's any friction, that it's not going to do what I want. And so, like, it's sort of like on ice now, where it just slides for a very long time. I mean, it moves a little bit now when you land, but really, I think I just, it's a little bit weird to use a physics engine for this particular thing anyway. It's not too weird, but it's not optimal, let's say. So I'm just going to set this back to 0 and see for the player controller system. So I already have everything I need right here. we know whether the player, so move left and move right is whether the player is holding down the, oh, hold on. Okay. Whether the player is holding down the left or right keys. This is like whether the player wants to move left or right. And then moving is whether the player wants to, move either left or right. And I also keep track of the horizontal velocity, which is really just, whether the player is actually moving or not. So what we want to say is if you're not moving, so this else is here as if not moving, which means if the player is holding either left or right, and then we can say if horizontal velocity. Well, actually, we need to also say if they're on the ground. Otherwise, they'll experience drag while in the air, which is not exactly what we want. So if they're on the ground, and let's put this in here. Horizontal velocity is greater than whatever, small value. Let's make this a little bit more awkward for the moment. Then you're supposed to apply forces to dynamic bodies, but let's just see what happens if we set the velocity. So for the x velocity, well, actually, if we're gonna do it like this, we can say if the absolute value is greater than 0.1. So what this means is now we can say you can set the horizontal velocity to 90% of what it was. And then this one doesn't change. We just want to set it to the y velocity that was before, which is probably going to be 0 if they're on the ground, but you never know. The other thing about this is this doesn't take into account delta time, which means if someone has if someone's getting 60 frames per second, they will slow down faster than someone getting 30 frames per second. That's not good, but I'm not going to worry about that at the moment. I'm just trying this out. Okay, I mean, that seems to be working. It's actually pretty good right there at 90%. But just well, also, I have it at 0.1. I don't think he'll actually stop. Yeah. And something else you can do is you can say, otherwise, if the horizontal velocity is something not 0. Hold on, let me see, is there any other... Yeah, so I mean, libgdx has this as 0, but all it does is check to see if there's this very small number. I mean, that's basically 0. I mean, obviously, that's pretty small. So I'm going to use that, actually. If it's not 0, so basically this means if their speed is under 0.1 or lower, but not 0, then just set it to 0. I wonder what that linear damping is about. Yes, I know what the method is called. I mean, because damping sort of sounds like what we want. Okay. Well, okay. I mean, this is okay. Whatever. That might be what I want, but well, I'm not going to worry about that right now because fiddling with this by hand is all right. Like, I know you don't want to set the position of things by hand. I think this print statement is causing a bit of lag, so I'm gonna turn that off. Writing to consoles is surprisingly expensive. All the scrolling. There we go, much smoother. Mostly. So you can jump. And whatever. Okay. You may have noticed, I don't know, it's bothering me a little bit, but the sprite sheet that I got, that I'm borrowing, it actually has squares drawn on the sprite sheet, which is great if you're looking at it and you're trying to measure pixels, but if you just use it directly in the game, then it actually renders the borders, and it looks sort of like this raised button, almost, and I don't know, I'm still just messing around, so I'm not going to worry about it too much, but yeah, I'll fix that at some point. So let's see, this was sine wave plus improving drag, because we're managing it by hand now. Previously the landings were getting stuck. Okay, so one of the things that looks terrible right now is the terrain is just these empty boxes. Well, one thing I want to do first is just lower it, because it looks silly. I mean, it looks doubly silly because it's just floating in the air. So well, let's just lower that number. Okay, let's lower it a little bit more. Okay, that might be as low as I can get it. Maybe I'll use fractions, fractional amount. Okay, whatever. That's close enough. One thing I've noticed is, well, I'm not sure if this is a feature or not, but you can. It looks like sometimes it's possible to jump without leaving the ground. I mean, because the feet box is, you can say it's a couple pixels tall. I think sometimes it doesn't register you as having left the ground yet, so you actually you can jump. Like I could jump from here. Yeah, so you can see the jump height varies by a fair bit, and I might just need to say you can only jump once every half second or something. Right now it's sort of handy being able to jump really high. The other thing that I thought was sort of funny was this character, the circle is a 0.5 meter radius, so the height of the character is, I mean, technically 1.5 meters. It's a little bit short, but this is a reasonable walk speed, I think. But he's actually moving at 4 meters per second. He's moving very quickly. When I tried having it at 2, it just seemed painfully slow. Oh, and you can also hold on shift to run, and it makes the animation play twice as fast, which was nice because that was pretty easy. Anyway, so back to making the boxes less, well, less transparent anyway. I saw, so, let's see. I saw something on OpenGameArt earlier. So this one's nice because it's public domain. But if you imagine like, so I'm probably going to shrink these down, but if you imagine just using this one for the inner terrain and these ones for the top terrain, I think that, it's probably not the art style I'm going to go for, but it looks alright. Okay. That's what we just saw. Sample is probably the other one. Okay, well that sort of sucks that they're all separate images, which is not great because you really want a sprite sheet of all of them. I also don't really understand his numbering, but whatever. So I don't know, maybe I can reuse that one too. So I'm just going to extract this into the assets directory. And let's plop it in jungle, let's say. Okay, well this is, I'm going to leave that in there. Okay, so the one we're interested in right now is Jungle Pack 35, for whatever reason. I have a asset manager going right now, and if like I have a file in here and I call load, I wait for it to finish loading, and then there's an assortment of helper methods to get the texture regions and a list of texture regions. One little trick that I haven't gotten to use in Kotlin until now is Kotlin has a array class itself. This is Kotlin's array, but confusingly, GDX also has its own array, which isn't too bad. But if you want to use both of them in the same file, you have to import. You either specify the fully qualified name, which sucks, or you can do this as GDX array, which is great. So now I don't have to worry about that. I don't have to write out the whole thing, and I can tell what it is. Anyway, so let's write the next one out. Private val dirt inner file name, and this is going to be. Remember, this is relative to the assets directory. So this is jungle PNG, and was it 35? Yeah, 35. Okay, that's probably right. So let's load that guy. And pretty much I don't know if this is always the case, but the lowest level image format that you want to import is always going to be a texture. And you can wrap that in sprites and texture regions, but you still got to import the texture, to my knowledge. Okay, so now we have all this other sprite stuff going first. Get rid of all that. And now we have dirt inner. This is going to be texture. And that one's a little bit more complicated because, okay. Let's look at this one. Turn asset manager to get dirt inner file name, and it's the same. I don't really love how you load something of a particular type and then you have to call get something on a particular type. Like if it just returned a future or something, it would be less duplication. But whatever, this works. I'm gonna leave it as a texture, but this is dirt inner, and that's about it. So I'm gonna mark this as resources. Yeah, okay. So next thing is to actually draw this thing in place, and we don't have a system for that yet. Okay. So if you look at the game world generator, I generate all the world stuff here, but there's no entities or anything, and I think I'm not sure. So okay. First, let's make sure that file is loading correctly. Okay, so I mean you can't see it, but it's not crashing, so that's good. There's a lot of entities here. Like just this section is 8 by 6, 48 entities just right here. And if you're not smart about, you know, if you have an entity for every image in the entire world, for every cube in the entire world, that's sort of needlessly expensive. So what I'm going to do instead is I'm not just going to do it the wrong way like I normally do. I'm going to make it so that generate returns. So right now this generates the world, and as it generates the world, it's creating bodies and stuff. But really what it could do is it could just return a two-dimensional array and say what goes in each section. So I'm going to go ahead and do that. Two-dimensional arrays in Kotlin are sort of weird. Like in Java you can just say, you know, double bracket, and it sort of looks like, I don't know, not terrible. But here you have like a nested generic, and it's sort of odd. I'm going to create an enum. So I mean, so the question is like, what is it here? Like if it's a Boolean, then it's just, is there dirt there or not? And eventually there's going to be something other than dirt. There'll be minerals or different biomes or something. So that's not very long term. So we can just say, this isn't very long term either, but it's easy to rename something. Let's just say dirt, or there we go, terrain type, dirt, and we're not going to specify terrain type, we're going to specify optional terrain type, because when it's sky or whatever, it's easiest just to put null. I mean, we could have like different types of sky, I guess, but it doesn't really make sense. Okay, so we're not returning anything yet. So let's let's see. So I was just sort of like hacking around this before, trying to figure out what looked good, and unfortunately I can't really do that anymore, because the world doesn't really have strict bounding box. Like you can put things at arbitrary coordinates and it won't cause an out of bounds exception. Whereas now we want to actually populate, you know, with columns and height rows. Okay. I'm not sure if it's going to be a var or val at this point. So this is our array of arrays. Oh, okay, well, I can hear the wife coming down, so we've got other engagements, so I got to go. See you later.